Good morning, everybody. My name is Mr. Michaud, and I am so glad you are here for session 103, Introduction to OnShape. And I'm so glad to be with you all this morning. It's about 9 o'clock, so we are going to start. Let me go ahead and put the presentation on the screen here. Here we go. And all right. Okay, so my name is Mr. Michaud, and I'm going to hop forward a couple slides here because I realize I'm doing my own introduction. Here we go. And all right, so I'm Mr. Michaud, and I work at Marist School in Atlanta, Georgia, and I teach 7th through 12th grade computer science, design, and engineering. For us, robotics is part of the school day, and we have 17 First Tech Challenge teams and 2 FRC teams. So we got about 150 students in robotics. We're going to be going through this session. This is meant to be an introduction to OnShape, as if you were, dealing with students for like the first time working with it. I like interactive sessions. I enjoy being a classroom teacher. So I've been instructed by the moderator. If you have any questions or anything like that, you can raise your hand, click the raise hand icon, and then the moderator can unmute you, and you can feel free to just interrupt or type things in the chat, because again, the more questions you ask, the more we can kind of tailor the experience to what you're learning here, to what we're working on. All right, so going back to the first slide. So again, our goal is computer-assisted design, elements with OnShape, specifically focused on First Tech Challenge. This next slide right here, these are the links for some of the material in the workshop. And I'm going to hang on here for a second. The top link right here, this nevomusic.net/FTC, and then the words design elements OnShape.pdf. What that does is that will take you to a link to this presentation. So if you like to follow along and have a hard copy of the presentation, I know I do when I'm watching these events, you can have that. The second link is a PDF to an instruction book I'll refer to later. And then I'm also going to refer to some videos on a YouTube playlist. So these are some links. Hopefully you'll be able to access the top one to get a copy of this presentation. All right, so I've already done the introductions. And again, I have a situation here where I'm trying to run 17 FTC teams and 2 FRC teams at the same time. So given kind of the unique structure of the way we run things, I needed to have some special considerations. I need to operate at scale. So when my students are building, it is really, really difficult to just let the students spread the parts out and go for it, because very quickly the parts get used up. So I need to have some way to formalize and organize the building process here. And computer-assisted design allows us to do that. It empowers my students to think visually in detail about mechanical systems without having this infinite supply of parts to work with. And the quicker I can move students from tactile CAD to being able to do it virtually, that really benefits the program. Some other special considerations, I need to develop visual thinking with my students. Can they visualize in your head what systems and subsystems look like? Can they see it moving in their head? Can they play it like a movie inside their thinking? And I also need it, because of the sheer number of students, I need a self-directed asynchronous CAD curriculum from beginners, from my 7th graders who walk in and have never done CAD before, all the way up through my juniors and seniors. And they need to allow students to find a way to work at it through their own pace. Therefore, what the OnShape does is it empowers us to build student thinking and allow for prototyping without having an extensive inventory. And OnShape allows to streamline collaboration between tools and teams, because it is an online tool. All right. Kind of another part of our introductions, and this is something I really rolled out this year with my students formally, is this idea of being aware of where they are in the phases of both competitive robotics and product design. So our phase 1, and again, this is borrowed from my seniors last year had a lot of input into this. I borrowed some from Stanford Design Theory and from other kind of design thinking sort of ideas. But really our phase 1 is our research and our skill building. This is where we work on, fabrication. How do we work with materials? How do we do electronics? How do we do programming? And how do we work on CAD? And what I emphasize with my students in phase one is we are not trying to design the final robot. We're not trying to put together a product that's going to play the game. We're going to isolate a specific part. We've been working on shooting for the past 2 days, and we're going to do a lot of experiments and CADs and programming just on that, just to research and build our own skills. And then our phase two is our design process, which we're probably familiar with. Our game analysis and strategy, writing a requirements document, doing a conceptual design, and then a detailed design, which is where the CAD comes in. We build the robot, test it and refine it, deliver it to the competition, and then document as we move along. In working with robotics teams for the past 20 years, I've noticed a lot of students love to be in this fabrication and testing refinement stage. And they will often read the rules, watch the game video, and they want to jump right into this. That is fun. It is for younger children. This is where they learn about the parts. But again, in terms of developing a team and in terms of working with multiple teams, if every student is working on fabrication and testing at the same time all season, we can burn through a lot of parts and pieces very quickly. You have to maintain this inventory that's far larger than what is possible, and it's just expensive. So what we're going to work on today is really looking at CAD for our research and skill building. So we're going to look at some design elements and some techniques and exercises students can do, maybe not specifically related to this year's game, but it will hopefully give them the skills that they can work with really any game or engineering type environment. So our outline of our workshop, what we're going to work on is summarizing the elements of OnShape. Here are the user interface. Here's how this works. Again, designed for the beginner, designed for someone who is new. Going to demonstrate, I'm going to fire up OnShape, and I want to demonstrate the sketch and parts and assemblies, and just to give you a visual of what it's like to use. Want to explore some First Tech Challenge CAD parts libraries that exist and how we can pull the parts in. And then finally, I want to introduce a textbook, there we go, that I use with my 7th and 8th and 9th graders that is just free to use to kind of help them get a good start in the foundations of computer-assisted design. All right. So again, if you have any questions during the seminar, please click raise hand. The moderator will open up your mic and you can ask a question to help it be interactive. Okay. OnShape topics, particularly using this software. And OnShape is similar to Autodesk, similar to Autodesk Inventor, similar to some of our other systems. Really, our CAD software is divided into 3 areas. First is this idea of doing sketches. And sketches are 2D drawings showing shapes, positions, and dimensions of part elements. A lot of times it is shapes and dimensions. I've been introduced recently to what is called the master sketch through the FRC design curriculum. I had students who were really good at that last year. And just to let you know, I'm constantly learning from my students, my juniors and seniors. They often get to the point where their knowledge starts to outstrip what I know. So I'm always learning from them. So, your first element is working with what are called sketches. Our second topic is this idea of parts. Parts are 3D shapes created by extruding and rotating and manipulate the 2-dimensional sketches. So again, we're moving from 2D sketches to 3D parts. And then an assembly is a collection of parts connected via mates to represent a subsystem or a finished product. All right, and that's where we're at there. When I first started working with Autodesk Inventor like 15 years ago, it was very not intuitive in terms of how these fit together. Again, it took one of my students, Mr. Barry Tanka, who sat down and really wrote a curriculum. And to this day, I still really base what I do based on what Mr. Tanka showed me back about 10 years ago. So here we go. All right, so tools and techniques. Your user interface, this is what it looks like when you log in. And I'll do a live login in a moment. But what we're going to do is go over sort of the different views you see on the screen here with OnShape. All right. When you are working with parts, this is what the user interface looks like. You have a row across the top, this ribbon with the different icons that represent the tools, which we'll talk about those in a moment. On the middle part of the screen is your workspace, is your area where the 3D rendering of the part occurs. Over here on the upper right is your view cube that shows you the way that you are looking into the space. And on the left is the features menu. This shows you what you're currently is in this part right now, what components make up. And then down here on the bottom, as you make different parts, they will show up in this lower left pane right there. The other user interface you have in OnShape, and again with OnShape, you're dealing with like 3 user interfaces. The other one is assemblies. And assemblies, you have a very similar layout. You've got your workspace area in front of you in the middle. You've got the ribbon of tools across the top. On the left-hand side, this is called the instances. These are the objects that are the other assemblies and parts that are in your project. And I didn't mention this before. What is constant is across the bottom, there are a series of tabs. And these tabs represent the different assemblies or part studios in your project. They are collected together. So again, our topics here, we're going to be dealing with parts, which are designing single components where you're going to draw and measure using lines, rectangles, and circles, extrude and fillet and holes, and parts are made up of sketches. And then you have assemblies, which are a collection of other parts. You use constraints to connect the pieces together, and it is in assemblies where you create the finished product. Okay, so some details about your sketch tools. When you're working with 2-dimensionals, the ribbon across the top, the sketch tools you're going to use most often are your line and circle and rectangle. Arc is another very useful tool, and the polygon tool. Really, for me, when I'm working with beginners, these first 5 tools, which are very constant and different 2D shape making programs, ranging from PowerPoint to Google Slides to really any sort of drawing program. And the other really important tool, and this is my favorite, is the dimension tool, which is located, I'm kind of hovering the green dot over it right there. This is really useful for making exact parts, and we'll demonstrate that in a moment. And I'm always reminding my students, sketches are your drawings, parts come from sketches, and assemblies come from parts. Your part tools, notice I went here, the ribbon changes. Now we're working in 3D, so our most popular tools are going to be extrude and revolve, the hole tool, which is over here, your fillet tool, your shell, your combine, which is not showing here. They actually call it group tool now. So these are your, actually the group is in assemblies, but these are your tools here within parts. And then at the assembly level, again, our 3 menus, what we have are our place, which is not really a tool, but it's sort of your intuitive clicking and dragging and moving pieces around. Your create or insert, free move and free rotate, joints and constraints, a joint or a mate. That's what these tools are up here. I've got the circle now in the fasten mate and the revolve mate. For first tech challenge, these are the 2 I use the most often. You also have the slider mate is the 3rd one. There are other mates here, all the way going down the chain. The 3 I really use most often are these first 3, fasten, revolve, and sort of a slider. The group tool is also very important. I'm going to hover it over here, and we'll kind of demonstrate that as we go. So your general process, just sort of verbalize it with the students. When I'm doing with this, I'll often verbalize it first. You create a sketch, you set your dimensions, you complete the sketch and return to the part. where then you use extrude or rotate to make it 3D. You add additional sketches as needed, and remembering that our sketches can be made on the 3 planes or on the face of the created part. When you're working with assemblies, the goal is first you put the assembly apart, you pick one point of the assembly to be sort of the center, and you fix it in space. You add the other assemblies, and then you use your joints or constraints to maintain the positions. Step files, that stands for standard exchange of parts or standard exchange of product. And a lot of your vendors, such as GoBuilda and Rev, they have an extensive step files in their libraries for their products. You find the page and download the part. This is really exciting because when my students want to build and work with materials, instead of them hunting around the lab to find some arcane part that might be on a shelf somewhere, they can go to the GoBuilda vendor. They can find the part and download the step file, and then they can design with it. And then we can decide, is this a part we need? Do we need to order it? We need to find it. And then we can import it in, and we'll demonstrate that when we get to the demonstration part of the workshop. You can export files for 3D printing. You right-click on your tab and select export, and then you can select your format. I found we have the Bamboo Labs printers here at Marist, and the step files have worked really well. We've also used Colladas and STL, but right now step seems to be working for us really well. So once you make something, you can export it as 3D printing. Export on my list of something to go over live. Okay. You can also create drawings, technical drawings, which I find this more so for FRC when we're doing like building instructions, when our CAD team makes up an assembly or a part, and then they want to generate building instructions for students. You right-click on a tab, create drawing, you select four views, then you can export it as a PDF. All right, we're going to go into the sort of the demonstration part very soon. I'm going to want to kind of remind us of our different links right here. If you are able to, I would suggest one thing you can try, depending on your screen and your workspace, try logging into OnShape, see if you can create an education account, and then kind of work along or try it just to see where we're at, especially if you want to look at the text here. I know it's really hard in these online to sort of follow along. That's why I tried to make a lot of written directions to try and have videos, because often it is the students, you need to give them time to sort of experiment with it. So if you're experimenting while I'm talking and demonstrating, feel free to click the raise hand button and ask a question. We can give you hopefully some live advice right here. All right. So these are the demonstrations I'm going to work through in our next half hour or so. I want to demonstrate how to create a part from sketches. Use an example from the textbook I have. Want to show how to import and access libraries from different vendors. How to import a step file from a vendor. How to create an assembly using the GoBuilda imports. Want to kind of show you a finished demo robot, what it looks like when it's all together from the 2024 game. And then show an example of a master sketch technique for modeling and design. And wrap up with sort of the idea of some best practices when designing assemblies and First Tech Challenge robots. So that's going to be our demonstration. And again, while I'm talking and working through, please feel free to raise your hand or click in the chat so that the moderator can kind of bring you on here. So let me go ahead and I'm going to escape out of the presentation. And I'm going to move over into OnShape. The address is onshape.com. If you are new to OnShape, OnShape has this really neat program that you can sign up as an educator or in the education account. So if you have students, your students on your teams, they can create education accounts for themselves. If you're a teacher, you can create an education account. I'm a little unsure what happens if you're a mentor or a coach. That's something that we can look up. But that's the education account really is the way that you can collaborate. Want to open up a incognito window so I can show what it looks like if you're looking at the OnShape and you're not logged in. Okay, so if you're going to log in for the first time, there is something. There's a tab here to create a student account, and you can do that. When you create a student account, it is going to prompt you for your age and school, and there's a process to go through that. I'll tell you with my students, I usually have them create the account a couple days before I plan to use it. And what this does, this gives them some time to sort of work out the bugs of creating a password and logging in. They have to get a confirmation email. So that's where that is there. In the textbook, what I tried to show, I'm going to bring up the textbook for a second. So find it here. And I've got a little board blindness, but that is okay. There it is. I try to make these as a PDF. That way you could just print them or download them if you needed them. On the opening pages of the textbook, these are some slides. There is directions on how to log in and set up an account. The screenshots I've got here might be a little dated. I think the last time I edited this directly was a few years ago, but the principles is the same. This is the directions I give to my students when they're filling out. So they can fill this out, and generally if they follow these, they're going to be able to log in and use OnShape right there. Okay, so when you are logged in, you're going to be presented again with your user interface. It's going to look something like this. It will remember the projects you've done in the past. I've got a lot of projects on here. On the left-hand side, you're going to see Owned by Me. That's really where your work is. You can do some research. There's a way as an educator to set up what are called teams. So for my students on FRC, I do have this teams folder, which allows us to organize the students, and we all have access to it. It's sort of like a shared drive in Google Doc right there. I'm going to be today working mostly with Owned by Me, and that's where we're at. You can create a new document. You select Create Document, and that lets you create the document there. You can title it. Again, fairly intuitive. I'm going to go ahead and, oops, I just made a blank document. I wanted to go back to the one I was kind of working on for the workshop here. So I'm going to go back and load up this document right here. Just ones I've made some demo tabs for us. Okay, so right now I've got an existing workshop. And when you start a blank project, it will look like this. I will tell you for students, and hold this up right here, this humble, old-fashioned wired mouse, my Amazon Basics mouse, this is a kind of a must-have when you're working with OnShape, with the CAD. It's designed to work with a mouse. Some of my students, they get really fancy. They have special CAD mice. Some of my students figure out how to use the touchscreen and the stylus. I just tell them the minute they have questions and are asking about it and have trouble using the interface, I tell them to get a mouse. The middle wheel is your zoom. If you right click and drag, that is that's your tumble or your orbit. You can click on the corners or the face of the view cube to change the view. And then the shift key and the middle mouse button is your pan. With my students, often the first days or so we use this, we have to have a lot of practice with using mice. That is just not something that students today use. All right, so what I'm going to walk through is this designing a simple part. It's on page 12 of the textbook. I'll show you what it looks like in the textbook. So this is the first part. I think I pretty much borrowed this from an Autodesk 2024 manual, just this general shape. And what I tried to do is show them very step-by-step how to do this. In terms of teaching it, what I'll often do is I'll have them open up the directions without the computer. And first we'll verbally talk through the directions. Then I'll do it in front of them while we talk through it. And then I let them try it. The idea is that they have a couple times where they're hearing how it works. before they try, so they don't get this sort of instantaneous do as I do, follow along, where they have a hard time remembering. I use a good old-fashioned written textbook because we don't have to have shared screens in the class. And then if I need to, I can walk over to the book and I can just point to the page, read this number. What does this say? Again, for my younger students, teaching them how to really read and look at some of these details is a big part of the learning right there. So what we're doing, first step is I want to create a sketch. I want to sketch out this sort of Z shape. The finished part is going to look like sort of those classic CAD textbook kind of anonymous parts right there. The finished part's going to look something like this. So the first step is kind of showing the students, hey, we're going to look at this from the side view, and I'm going to make this like number 2 or this step shape. So in OnShape, what we're going to do, you always start by we're in a part studio. So we're going to start by creating click the sketch button. And then the first thing it wants to prompt us to do is to select a plane in which to do our 2D sketch. So I'm going to click the front plane, and notice we've got our 3 planes here, front, top, and right. So I'm going to click the front, and now the sketch is anchored to the front plane. Then I'm going to click on the front of the view cube. What this is, this orbits the view. So I'm just looking straight at it and it becomes really like a 2-dimensional view. Then I'm going to go ahead and sketch the part. So I'm going to click the line tool. And I'm not going to worry about what the exact dimensions are. In the book right now, it shows us these are supposed to be these exact dimensions. The first step is I want to get the general shape. So I'm going to click the line. I'm going to start here at the origin. I'm going to click once, starts to draw the line. Again, I'm not too worried about the shape. Click again. Click here. When the line is dotted, I don't know if you can see the sort of the yellow and blue dots. That means it's parallel. I'm going to move up. It sort of snaps to perpendicular. Move across. Down. Back to the y-axis, and then I'm going to return to the origin. And once I make a closed curve out of the shape, it turns gray. Some of my students, they absolutely get this right away. The first time they do it, you show them they're there. Other students, they get kind of twitchy with the mouse, and it's really sort of walking them through with my 7th graders. Here's how you do this. Again, I encourage the kids because sometimes they're doing this and they don't see the direct relationship to the game. And I'm reminding them that this is a phase 1 activity. You are building your skills right now. This is like an exercise. This is like practicing for a sport when you're doing a drill. All right, my next step is I want to use the dimensions tool. And this is my absolute favorite tool in the whole world. As much as I enjoy building, I'm actually a software person. So for me, like getting out the tools and the saws and the drills and trying to cut and measure gets super frustrating because sometimes I am just not as precise in my measuring and my cutting as some of my students are. So what the dimensions tool does, I'm going to hover over it right there. The dimensions tool allows us to create things with exact sizes. So I'm going to click the dimensions tool, and I'm going to go ahead and hover over the bottom. And with the text, that's going to be 2 inches. So I'm going to type 2 and press enter, and it pulls the shape into size. This one right here is our 0.25. This is 1.75. Okay, I'm not going to worry too much right now about it pulling. Oh, I typed it wrong. Okay, I typed it wrong. If I did, I can double click on it, double click on the numbers, and then put the right measurements in. 1.75 at the top. Then I'm going to make this end piece 0.25. And then finally, it's 1.75 for the line segment here on the left. And what that does, that's going to pull the shape into the proper dimensions. For my students, I like to show them this, the first idea, to get the sense that when we're trying to design with some level of precision. The nice thing is, once you set these sizes, if you decide you want it different, let's say you're refining your design and it needs to be 1.25, you can type that and it will resize and repull the shape. And this is where, for prototyping, it works out really well, because you can change your sizes as you're moving along. Once I'm done the shape, once I'm satisfied with the two-dimensional shape, I can click the green check mark and it accepts the shape. And now I'm back into part mode. I can double click on the sketch to go back into sketch mode. Notice how the tools change on the ribbon. And then I can exit sketch mode by clicking the green check. Then I can click on the corner of the view cube. It's going to orbit the view back to diagonal. And what I want to do is use the extrude tool. Again, this is one of those main tools we've got. So I'm going to zoom and pan so it's better. It's interesting, like I find I do a lot of zooming and panning. When I watch kids work with this, I always get a little seasick, because they're like zoom and pan and zoom and pan. And I'm always like, slow down. But zooming and panning, extrude, there's the tool icon right there. I'm going to click it one time. And again, it brings up the properties menu. I'm going to click on the face I want to extrude. And then I can set the depth of the extrude here in the depth column. So I can set it to different numbers. Again, if you've used programs like SketchUp or 3D, Autodesk 360, I think is another one. These are pretty familiar tools. Tinkercad is another one students might have experience with. And I'll click the check mark. And again, a nice part is, in this features area on the left, every step you do is remembered by the program. So let's say I decide, again, this length here, this bottom foot, I want that to be different. I can go back to the sketch and double click it. I can go back to the dimensions, and let's say I want to change, I'm going to change this number right here. Let's say I want this to be 3. When I click the green check, it'll automatically adjust the extrude to match. So a lot of times when I'm working with parts, what we can do, and put this back on the original number, which was 1.75. Another reason I want my students to kind of get used to working with a text, because in the conceptual design phase, I want them to physically make their own sketches on paper, or maybe an electronic document, but I still like paper pencil work so they can refer back to their drawings. All right, the next part of this is using what is called the fillet tool. I want to round the edges, so I'm going to click the fillet tool, and I can click the edge there, and what it does is it rounds it off. So in these directions here, so I have the children round off the edges. As I click each edge, it is stored in the list of the tool right here. I can change the radius. Gives me a different feel. Again, kind of that freedom. For this part, I'm going to show you, I'm not going to finish the directions that the students have in the book, but I do want to finish this last piece here, and that's creating holes on the shape. And OnShape makes cutting through surfaces really easy. I've used Autodesk Maya for teaching my animation classes, and Maya, in some ways, is so much harder to do this kind of modeling. Often I'll have students model in OnShape and then import into Maya, especially for things like cutting holes. So here we go. Let's say the idea with the directions, and I'll kind of move forwards, this is what I was showing, is we want to model and put a hole in the bottom of the part right there. So I'm going to right click on the part. This is what we're going to do. We want to make a sketch, but we're going to make it on the surface of the part instead of on one of the planes. So I'm going to right click on the part, and we're going to say new sketch. Now I'm drawing on the plane. I'm going to click the top view. So what I do is I've got a nice two-dimensional view of where I'm drawing. And then we're going to use the circle tool. I'm going to hover over the shape. And what I do is if I hover where the curve of this arc meets the rectangle, I can move down. It kind of makes this diagonal line or this dashed line. And I can find, OnShape will help me find the center. And then what I'm going to do is I'm going to go ahead and make a circle. And I'm going to set it to 0.5 inches. Whenever you make a 2D shape, as soon as you click it, OnShape gives you the opportunity to set the dimensions. So now I have a sketch of a circle. And notice here on the features, it's added another feature. So I've done 4 steps. I made the initial sketch. I did the extrude. I did the fillet step. And now I'm on sketch 2. You can, I believe you can name these as well. I'm going to click accept. Now the hole is not there yet, but we can see the kind of this gray outline of where the sketch is. Then I'm going to click the hole tool, which is up here. Now we're back in parts mode. I'm going to click it once. And again, you kind of see the pattern. It brings up some properties right here. I'm going to want a simple hole, our width of 0.25, and then our depth. I'm going to click it once, and it's going to create the hole. To change the diameter, I want it to be 0.5 to match the circle that I've drawn. I'm going to click that, and then it's going to make, that's how you cut through. And again, some elemental steps to what we are doing here with OnShape. I find with my students, I have them go through many variants of this because I'm teaching 7th through 12th graders. Usually my 7th graders, I have them do these elemental parts, and then each year they come back, I sort of have more difficult parts moving through. So by the time you get to the end, you are doing rotation and revolve. So that, again, something that I just tell the students to move through. From a practical side, on these robotics practices we have with kids, and you've got 6 kids in a room, 10 kids in a room. Some of them are building and some of them are coding. If CAD is in their library of skills, and you have children who are maybe new to the team or they don't know what to do, or honestly their skill level is not up to the team yet, you can sit them down with a CAD textbook or some of the other online tutorials, and you can say, you need to work through this. So a lot of times with my students, I try and emphasize the importance of building their skills right there. All right, the other part I wanted to talk about was importing libraries. So these are part studios. You can see I've got some different sort of sketches I did. We also have what are called assemblies. An assembly, I was working around some experiments. We're trying to design shooters for the game. Assemblies right here are where we're putting parts together. So the next item we want to demonstrate is how we can bring in parts from other builders. Because I certainly do not want to take the time and use the part studios and build out these pieces we can get from GoBuild or Rev. So what I'm going to do is I'm going to make a new assembly by clicking the plus sign down here on the lower right. I'm going to select Create Assembly. It's going to give me a blank assembly. Now, what I've done, if you choose Insert, this is how you can insert parts. Right now, I'm in my document, and the only parts I've got made are the geometry study that I did last night, the part studio I just did now, and this is a part a long axle I imported from GoBuild. But what's really great about the collaborative nature about OnShape is I can click this middle piece that says Other Documents. Okay, and then I'm going to go back. I'm going to go to Home right here, and this lists what I have access to. I've got Marist Robotics. I've got my own documents. Here's some shortcuts of what I recently opened, what's shared with me. These are some teams that I've got for robotics. But what's really exciting is this option down here that says Public. If you click on public, there are people all over the world who create projects and libraries in OnShape and then share them. So what I did for my students is I had some of my interns once go through the entire Go Build a catalog and download all the step files and put them into one project so it's easy to, so my students, I can access it quickly. There are many other people that have done that as well. I'm going to type Marist FTC, and you have access to this. And if you do that, there's this library that's called the Marist Go Build a FTC Kit Parts 2022-2023. Each year I add parts to this depending on what comes current this year. This year I'm going to have to add the one-to-one motors, add some different belts, some of the newer parts. But if I click on this, this gives me access to most of the Go Build a catalog. All right, there are parts, and then there are assemblies. What I encourage the students to do when they're building and designing, I teach them right away about the SKU numbers, the product number. So in the directions, and let me fast forward to the part of the directions where we're talking about building and designing robots right here. What I'll say is, all right, if we're going to build this assembly, we need these parts. So they have a part number. They've got the name of the part, and then I do a screenshot of the image. When the students are putting together their engineering documentation, they have to do these same kind of charts. Because again, I want to teach the students to be able to empower other people to build too. So once you create a design, you should create a way for other people to build it, especially to bring more people in on your team. So let's say I'm looking for this 10-hole U channel. I've got my part number. There it is. I can go to OnShape. I can start typing the part number, 1100, and sort of filters out. And what I wanted was the 264 millimeter U channel. So I click on that, and that brings it into the world. I can click there. And let's say I want a quad block. Quad block is a 1201 family. Go back over here, 1201, filters it out. There's my quad blocks. And that's how you can import parts into the world. You can also just visually search. The issue is this library is just so large, and the icons wind up showing up here. Sometimes they're really tiny. They're hard to see. And that's where we're at. Wanted to demonstrate using the mates. Again, this is something that the first time I'm working with my students, sometimes it's a little bit tricky. And what I'm going to do, I'm going to go over to, actually, I'll show you on here first, and I'll show you on some pre-collected. So the idea is, for this piece, I want to get the quad blocks put onto the top of the shape and holding on the top of the shape like what we see here on top of the U channel. So what I'm going to do, first, I'm going to flip the quad block, this one, so it's in the right orientation to match going on top of the U channel. Clicking the quad block one time, there are these move and rotate handles. If I use the arrows, that allows me to sort of slide the piece along your X, Y, and Z axis. The circles with the little lines in them, these are your rotate handles. I can grab and rotate. I'm going to type 180 and press enter. And that rotates it to the right orientation. You don't have to when using constraint parts, but I find it's easier when you're putting things together if they're close to the proper orientation before you start. Going to use our fasten mate. Click it one time. And then there's two steps here. I want to choose. I'm going to hover over this circle, and I want to choose. I'm going to move around until you see in the middle of the circle, there's this blue and red and green anchor point. I'm going to click on that. That's first the part I want to move. I'm going to go back to the rail. I'm going to orbit over, find the inside of where I want it to match, click again, and it brings it together. I remember when a student showed me this back in 2016, and it was changed. It just rocked my world. I
Hey,
remember yes,
sorry to interrupt you.
5
There's
minutes
five
left.
minutes left. Yeah,
Okay.
and also there's a question in the Q&A.
Oh, okay.
Um, yeah.
Great. Q&A. That would be in the chat.
Hold on. I'll just post it in the chat so you can see
Okay.
it. There you go.
Oh, is this the question that says, how can I get these materials, sir?
Yes, yes.
Okay, fantastic. So what I'm going to do is, thank you so much for asking. I'm going to go back to the slide deck. And on the slide deck, I'm going to copy the URL of the PDF, which has a link to everything. So these are the links right here. And the one we want is this one. Let's see if I can grab that here. Copy it. I'm going to paste it into the chat. Press enter. Does everybody see that?
Wait, hold on. I'll just um let me just
And again, I'll bring it up so everybody can see it. Here we go. Move the webinar chat panel out of the way. So the links to these materials, it is all right here. The one that really kind of this master link, this top one, will take you to this presentation. And then from this presentation on slide 2, there are the other links, and you can use those. The YouTube playlist right here, what the YouTube playlist is, way back in COVID, I made hundreds of videos for students. I think we all did if we were back in the teaching days. And what these videos are, if you start kind of in the middle, and they're not really loading right now, there they are. You kind of have to start in the middle because I talk a lot about programming in the beginning. But if you start in the middle, there are OnShape tools and techniques. Like what I'm showing you, part work through, they're all here. So you feel free to use these for your students. All right. But I tried to make it, I just made a ton of videos. And again, they're all linked here, and you can pull them up. All right. Okay. I know we've got about 3 minutes left. I just got so much into demonstrating. It's so much fun. Wanted to show you how to download from a vendor. Let's say you go to GoBuilda. And let's say you look up a part. I want to look up an axle. Because this year, I happen to need all these long axles because it's a shooting game. And the students are needing these axles right here. There they are. And let's say I've got all the axles I have are the short ones. So let's say I want to import one of the longer ones here. I can click the part number. And often what you do on these vendor websites, if you scroll down, you'll see this called a step file. Download the step file. It's a little tricky because a lot of times the step files will come in as, and I realize you guys don't see my screen, my whole screen. They'll come in as zip files, but you extract the zip file. Then once you extract it, which I know you didn't see that, go back to OnShape. You can use import, right? Then you go to your downloads, which my system dialogues come up, and you guys can't see that, but I'm going to go to downloads, and if I select the file 216, I can import it, and then it will take the time. It talks about importing it. I'm just going to click import, and then it will work on bringing in the part. I know we've got about a minute left. Thank you so much for being part of the presentation. Please, you can use any of these. My email, let me see if I can type this on here really quick. It is mishoc@marist.com. That's my email. Feel free to email me anytime if you have any questions or have access to the material or questions about starting computer-assisted design. We really only scratched the surface in our hour. And I just thank you so much for being part of the presentation. I hope you have a great symposium weekend.